Chapter 7 Mass Spectrometry Part 2. These are some of the useful videos. Please click at the link and view all the videos. As a recap, the mass spectrometer is divided into three fundamental parts: the ionization source, the mass analyzer, and the detector. So in this chapter 7 part 2, we will look at 6 ionization source, 6 mass analyzer, and 3 detector. How does a mass spectrometer work? First, we will talk about sample introductions. So it depends on the ionization method being chosen and used, which we will discuss later, the type of sample, and sample complexity. So sample can be inserted directly into the ionization source or can undergo some type of chromatography en route to ionization source. So the commonly used chromatography are HPLC, GC, or capillary electrophoresis separation column. So sample will be separated into a series of components by chromatography, which then enter mass spectrometer sequentially for individual analysis. And then the methods of sample ionization is very important in MS work. Many ionization methods are available. Each has its own advantages and disadvantages, which we will discuss in detail in this chapter. Okay, ionizations to be used depend on the type of the sample, okay, under investigations and available mass spectrometer. And this is very much depend on how much budget we have. Let's do some revisions. What is ionizations? Can you remember? Ionizations is a process by which an atom or a molecule acquire a negative or positive charge by gaining or losing electrons to form ions. There are 6 ionization methods in MS. They are electrons impact ionizations, fast atom bombardments, chemical ionizations, electron spray ionizations, atmospheric pressure chemical ionizations, and metric assisted laser desorption ionization, which is known as MALDI. We will start with the first ionization method, okay, which is electrons impact ionizations. It works by volatilizing a sample directly in source that is contained a vacuum system that is typically directly attached to an analyzer. Gas phase molecules are bombarded by a beam of electrons formed by heating a filament biased at a negative voltage compared to source. The mass range is up to 1000 daltons. Commonly used ionization method, okay, techniques. Consider a hard ionization technique because it causes ion to fragments. So most commonly used for GCMS. The advantages for EI, it can be applied to virtually all volatile compound, reproducible mass spectra, fragmentations provide structural informations. Library of mass spectra can be searched for EI mass spectra, which is using fingerprints. The limitation sample must be thermally volatile and stable. Okay, molecular ion may be weak or present at for many compounds. The second one is fast atom bombardment, FAB. It is a first commonly used technique. It is the ionizations of non-volatile compound, for example, glycerol, done by bombarding a sample with a fast beam of atom, such as argon or xenons, accelerate to kilovolts energies. Sample is typically mixed in a matrix. Most commonly used are glycerol or trinitrobenzoic acid. Cluster ions from both sample and matrix are dissolved and produce a chemical background that varies with matrix use. So the mass range is up to 6000 dalton. The advantages of FAB, it is rapid, simple, relative tolerance of variations in sampling, good for a large variety of compound, strong ions currents, good for high resolutions measurements. Their limitations are high chemical background, define detection limits, may be difficult to distinguish the low molecular weights compound from chemical backgrounds. Okay, analytes must be soluble in liquid matrix. The third one is chemical ionization, CI. The interactions of sample or analytes with a large amount of reagent gas. So use ion molecules reactions to produce ions from analytes. Commonly used gas, methane, isobutane, ammonia. Process begin with a reagent gas is ionized by electron impact. A high reagent gas pressure or a longer reaction time results in ion molecules reactions between the reagent gas molecule and reagent gas neutral. In chemical ionizations, some of the product of these ion molecules reactions can react with the analytes molecules to produce analytes ions. It is suitable for small molecular weight samples such as ammonia. So you can refer to the chemical ionizations of ammonia as below. The mass range is up to 1000 Dalton. The advantages of chemical ionizations are it offers molecular weight information through molecular light ion, for example, M plus H positive. A simple mass spectra, reduce fragmentation in comparisons to EI. The limitation sample must be thermally volatile and stable. Fragment pattern may not be informative or reproducible enough for library search. So results depend on reagents gas type, pressure, reactions time, on natures of sample. Electrospray ionization is a soft ionizations that yield intact analytes ion with one or more charges. A high voltage is applied to a liquid stream. Heat and gas flow are used to dissolve ions existing in sample solutions. The mass range is very high, up to 200,000 Dalton. The advantages and the limitations of electrospray ionizations. This ionizations methods is good for charged, polar, or basic compound. It permits detections of high mass compound. It is the best methods for analyzing multiply charged compound. Low chemical backgrounds leads to excellent detections limit, can control presence and absence of fragmentations by controlling interface length potential. It is compatible with MS-MS methods. Okay, the limitations, multiply charge species require interpretations and mathematical transformations. However, we have database. Complementary to APCI, no good for uncharged non-basic low polarity compound, very sensitive to contaminants, for example alkali metal or basic compound, relatively low ion currents. The next one is atmospheric pressure chemical ionizations, APCI. It is the same interface as used by ESI. A corona discharge is used to ionize analytes in atmospheric pressure regions. APCI is more suited to analysis of relative non-polar molecule, however still within the scope of LC separations. ESI and APCI are complementary methods. Okay, the advantages, it is good for less polar compound, excellent LC-MS interface, compatible with MS-MS method. However, the limitations is the complementary to ESI. So therefore, sometimes in some of the textbook, they didn't mention about APCI. Metric assisted laser desorption ionizations, or also known as MALDI. It is an ionization techniques whereby sample is bombarded with a laser. Sample is typically mixed with a matrix that absorb laser radiations and transfer a proton to sample. The mass range is very high, up to 500,000 Dalton. Here are some of the example of Maldive matrices: synaptic acid, DHP dihydroxybenzoic acid, alpha-cyano 4-hydroxycyanamic acid, 3-hydroxypicolinic acid. So this is a 3HP. In MALDI, some small masses sample can be ionized without matrix laser desorptions. Laser is always pulsed and typically in a vacuum, mostly forms singularly charged ions. So it uses a small soft ionizations method. It preserves intact analytes, and it couple well with to tough instruments. The advantages of multi-rapid and convenient molecular weight determinations. However, the limitations are such as MS difficult, require a mass analyzer that is compatible with pulse ionization techniques, and it is not easily compatible with LCMS.